Let's begin today's review of the moon and the phases and the eclipses by first talking about the different motions of the moon. Now, we've talked in class and we have discussed the idea that it takes the moon 27.3 days to revolve around Earth one time completely. In that same amount of time, the moon will rotate once on its axis, making a lunar day and a lunar year, a lunar rotation, and a lunar revolution equal to the same amount of time. Now let's compare that time to the amount of time that it takes the moon to complete a set of moon phases, or complete lunar cycle. If we put the moon in a position to be a new moon, where it's going to be straight in line with the sun, we look at this as a clock. 12 o'clock is here, so the moon is at roughly the 2 o'clock position. The moon will now begin to revolve around Earth. When the moon gets back to the 2 o'clock position, as Earth has moved in its revolution, the moon is no longer going to be in that straight line with the sun. The moon is no longer at the new moon position. At the position that it's at right now, this would be a waning crescent. This is taken, as we just talked a minute ago, 27 3/10 days. As Earth continues to move in its revolution, the moon needs to move a little bit further to get back into that straight line with the sun, which we should be able to clearly now see that that's closer to the 11 o'clock position, but now it's back in a straight line with the sun back to a new moon position. This will take 29 5/10 days. If we were to do the math and work that out, we're going to see that it's going to take about 354 days to complete 12 cycles of moon phases, not the 365 days, 365 and a quarter days that are in a year. That's why the moon phases don't happen on the same day from year to year to year. Okay, so now let's go ahead and let's look at the orbits of both the moon and Earth, and we'll talk about their orbital planes. We've talked about the orbital plane before, and the orbital plane is the level or the line that any of the objects follows as they're orbiting around the sun. Okay? The moon's orbital plane brings the moon either above or below Earth's orbital plane most of the time. This plane is tilted at 5 degrees from Earth's orbital plane. That puts the moon either above, that puts the moon either above Earth most of the time, or it puts the moon below Earth most of the time. Okay. By being above Earth or being below Earth, no shadow from Earth is going to be cast on the moon. So if we were looking at the moon, we have the sun over here. Light rays are shining on the moon. Light rays are shining on Earth. So we should be able to see our photo dark side of both objects. We're looking from above right now. We can see from Earth that we should be able to see lit up portions of the moon. When the moon orbits and gets to the position of being in front of Earth, But below Earth, depending on where we happen to be, again, we may be able to see the moon. So in this example, see the moon is below Earth. Again, those sun rays will be shining on both. So again, we'll be able to see that photo dark side of both objects. But again, it's below Earth. Shadow is not blocking the moon, so again we can see the moon. Now let's look at the moon in all the different positions that it can be in. This time I'll keep the sun just on one side. In this picture, we're not going to be moving Earth, so please just realize that. I want you to realize that the inner circle in this diagram our perspective is an overhead view. Okay, that would be these right in here. I want you to then realize that the outside circle is what is viewed from Earth. Okay. Now, we can see that the sun is shining. We can clearly see the photo side of the moon and Earth always in yellow. And we can see that half of the moon is always lit. Depending on where you happen to be standing, and that's what I mean by viewed from Earth. Depending on where you happen to be standing, what you see out in front of you is going to be within that cone. So when we're at that solar noon position, a new moon phase, we can see that from Earth, we're looking at the dark side of the moon completely. Opposite that one, an easy example, if we're standing sometime around midnight and we're looking up into the sky, we're seeing the fully lit up portion of the moon, 100%, so it's going to look like a full disk. Please remember, as we look at this, you have to go back to what we just talked about, and in these illustrations right here, this new moon and this full moon are either above Earth's orbital plane or below Earth's orbital plane, so we can see that. If we then move to, let's say, our sunrise time, we can see that as we look from Earth up at the moon, we're going to see 50% of the lighted side and 50% of the dark side of the moon. This phase, the last quarter, the third quarter, is going to look like a backwards capital D. As we move from the last quarter back to the new moon, the 50% of the lit up side that we see is slowly shrinking for us. And it's going to go from 50%, say down to 41%, to maybe 35%, and it's going to keep decreasing. And as it does, we see the waning crescent phase. And we'll see that banana of a moon slowly shrink. Now once we get to the new moon, we're at 0%, and now we're headed back towards a first quarter. And that first quarter is when we're going to again see 50% of the lighted side, 50% of the dark side. So we're going to start from 0%, get up to 50%. And again, if you look right at this picture, you can see that a small portion of the lit up side is actually in your sight. We're going to see the waxing crescent slowly grow. Okay, now again, because this is a still picture, so that we can fit it all, you don't see everything that we talked about the first time. We know that this is going to take 29 and 5/10 days to start at the new moon and to go all the way around, hit each of the phases, and get back to the new moon. If we look at that number, we should be able to look at some math and say, okay, that's roughly a month, roughly 4 weeks. So if we look at the 4 major phases, the phases that I've referred to as the non-transitional phases, we should see that those are going to be roughly 4 weeks apart. We're talking in the neighborhood of 6 to 8 days between those major phases. So now that leaves us 5 to 7 days for the transition phases. So 5 to 7 days of that sunlit percentage growing. We're at 50% here. We're going to get to 100% here over those 5 to 7 days. It will slowly creep up. So we may go from 50% to 57% to 62%, etc., until it gets up to the 100%. At that point, now it's going to slowly creep down, and we're going to see the waning gibbous slowly shrinking. And again, we're going to have the idea of going from 100%. It may go down only 1%. It may go down to just 99%. And then the next day it may go down to 92%. But it's going to slowly shrink until it's back down to 50%. Again, taking 5 to 7 days to go through that transition. Okay, so again, the thing that we've talked about is the relative position of the moon in relation to the sun and earth. So we can clearly see that sometimes the three of them form a straight line. Okay? Sometimes we can see that it's not a straight line and it actually forms a right angle. And that right angle is what allows us to see the moon from a different perspective. And then from there, we have all sorts of angles that we're looking at the moon that allow us to see either less of the lit up portion or more of the lit up portion. Okay, so now let's get to that idea of a lunar eclipse. The thing that so many of you thought when we looked at the revolution of the moon from above, seems like they should always happen during a new moon and a full moon. Well, you guys are right in saying that those eclipses are going to happen during those phases. But as we looked at it a little bit more closely, we investigated using the software that we had, we realized that the eclipses, are closely associated with the equinoxes. And the reason for that is that happens to be when Earth's orbit is such that the moon's orbit crosses Earth's orbital plane either when it's between Earth and Sun or when it's behind Earth, so that Earth is in between the Sun and the Moon. Okay? Now what we did was we looked at Earth, we looked at the Sun, we looked at the Moon, and we drew in some lines to help us see the angle at which the Sun's rays are going to go past Earth. Okay? And if I just draw these two lines for now, we can see that that cone that forms behind Earth is rather large. If the moon passes directly, as you guys have said, directly, or 100% inside that shadow, we're going to have a total lunar eclipse. The shadow that we're talking about right here is known as the umbra. Okay? That's the darkest part of the shadow. We looked at a little bit more with the lines just so that we could then get this idea also of the penumbra. And what happens is we draw this extra line here. We draw this extra line here. We still have our cone that is our umbra, but now we also have some outside portions of that shadow right here where the shadow is not as dark, and those parts of the shadow form the penumbra. Okay. As long as the moon is completely in the umbra, we have a total solar eclipse. If instead, and let me change the moon to an orangish color so it stands out here. If instead the moon were just at a point of crossing the orbit, either above it or below it, part of the moon will be in the umbra and part of the moon will be in the penumbra. And we're only going to have a partial eclipse. Now the same is going to be true during a new moon phase when the moon is passing between sun and earth. The shadow is going to be cast behind the moon, forming that cone. Now because earth is a little bit bigger than the moon, and the moon cannot cast such a large shadow, part of earth will now be hit by the shadow part. And that part of earth right there would be in a solar eclipse. The darkest part of the moon's shadow is going to fall on that small surface of earth, and it's going to block out the sun. Now, when this happens, we're going to go from seeing the sun as the whole thing to the next one where we have the sun, but we now have a piece of the moon. We now have a piece of the moon that's in front of a piece of the sun. And we're slowly going to see the moon crawl in front until the sun is blocked. And I would just continue to do that until that moon has crawled all the way up. And in the end, all we would see would be the moon with a whitish halo coming up from the sides, which I'm going to have to draw a yellow here because you'll never see the white. But you're going to see that little bit of sunlight shining right around it. And there's our solar eclipse. Okay, so if we were to recap everything, the big thing comes down to the relative positions of the three objects. Okay, what is their alignment? And based on this alignment, what can we actually see? Well, if they're all aligned on the same orbital plane as we just looked, we're going to have eclipses. If the alignment is a straight line, but the moon is either above Earth or below Earth, we're going to be able to see the moon. We're going to see the different phases of the moon. Make sure you take the time to go through all of your vocabulary, redraw some pictures if you need to, and make sure you come to see me during class, during ATT time, with any questions that you have.